Welcome to The Explainer. You've probably heard the term deep learning thrown around a lot, right? Well, today we're going to pull back the curtain on what is, without a doubt, one of the most powerful technologies of our time. We're going to get into how it actually works, why it's such a big deal, and how it's literally reshaping our world as we speak.
All right, so here's our game plan. First, we'll tackle the big problem that started it all. Then, we'll get into what deep learning actually is, peek inside the brain of the operation, see how it's leading to this massive shift with foundation models, and finally, what it all means for building with AI today.
Okay, first things first. To really get why deep learning is such a revolution, you have to understand the problem it solved. And it's a big one. A challenge that had computers stumped for decades. We're talking about making sense of all the messy, chaotic information out there in the world.
I mean, just think about it for a second. You look at a picture, and boom, you instantly know what's in it. A cat, a car, a face. It's second nature to us. But for a computer, that same picture, it's not a picture of anything. Not really.
To a machine, this image of a boat isn't a boat, it's just a giant grid of numbers. Every single pixel is just a value for color and brightness. That's it. So the billion-dollar question was, how in the world do you teach a computer to look at this ocean of numbers and see a boat? And that question, well, that brings us right to the breakthrough, the key that finally unlocked this puzzle. This is where deep learning steps onto the stage, and honestly, just changes everything. So what is deep learning? You can think of it as a technology that's basically inspired by the human brain. The core idea is that instead of trying to understand everything at once, it passes data through stacks and stacks of layers. And each layer gets a little bit smarter, learning to spot slightly more complex things than the one before it. But what does learning high-level representations even mean? Well, let's go back to our boat example. The network doesn't just see boat. No way. The very first layer might just learn to spot simple things, like a straight line or a dark corner. The next layer then takes those lines and corners and learns to see curves or simple shapes. Then the next layer combines those shapes into, say, the hull or a mast. It builds up piece by piece until the very last layer can look at the whole collection of patterns and confidently go, yep, that's a boat. Okay, so this idea of layered learning is cool, but how does it actually work? What's going on inside this digital brain? Let's peel back the layers, literally, and take a peek under the hood.
What you're looking at here is a simplified map of a neural network. On the far left, you've got the input. That's our grid of pixels from the image. Then, that data flows through the middle part, these so-called hidden layers. This is where the magic happens. This is where all that pattern recognition we talked about takes place. And finally, on the far right, you get the output, which is basically the network's final verdict, its best guess at what it's looking at.
So you can really break it down into 3 simple steps. 1, raw data goes in. 2, it gets crunched and analyzed through all those middle layers. And 3, a clear, final prediction pops out at the end. Simple as that. It really is like a conceptual assembly line. You know, the first worker just spots the nuts and bolts, the edges and corners. The next worker puts those together to make a small part. And it just keeps going down the line, getting more and more complex, until at the very end, the finished product rolls off, a complete idea, like boat, or dog, or car. Okay, so this layered learning thing is powerful. But what happens when you take this idea and you just put it on steroids? I'm talking scaling it up to an insane degree with billions of connections and feeding it a huge chunk of the internet. Well, what you get is the single biggest shift happening in AI right now, something we call foundation models. You see, the old way of doing things was, well, a real grind. If you wanted an AI to translate German and another one to tell you if a movie review was positive, you had to build 2 totally separate AIs from the ground up. It was a ton of work. Foundation models just blew that whole approach up. The new idea is, let's build one massive, super smart model that's already been trained on everything imaginable. Then we can just tweak it a little bit to do all sorts of different tasks.
And when I say massive, I am not kidding. Let's talk scale. A parameter is kind of like a knob the AI can tune to learn something. It's a connection. Early AIs might have had a few thousand of these knobs. GPT-3, one of the first big foundation models, had, get this, 175 times billion. It's that mind-boggling scale that gives them their power, turning them into these incredible general-purpose tools.
So, okay, these giant models exist. What does that actually mean for us, right now? Well, it's opened up a completely new frontier for what we can build. This right here is the game changer. For the longest time, AI was about analyzing stuff that already existed. Is this a cat or a dog? Is this spam or not? But now we're in the age of generative AI. These models don't just analyze data, they create it. They can write a poem, generate a photorealistic image, write code, all from scratch. And this is a super cool look at how something like a text-to-image generator actually works. It's called diffusion. Check it out. The model starts with what is basically just random static, pure chaos. Then, using your text prompt as a guide, it starts chipping away at the noise, bit by bit, refining it over and over until a clear image emerges. It's literally pulling a coherent idea out of complete randomness. It's wild.
And what's so interesting is that because these huge, powerful models already exist, the job of building with AI has totally changed. It's not just about spending years training a model anymore. It's given rise to a whole new discipline people are calling AI engineering, and it's all about building cool stuff on top of these existing models.
Yeah, and this chart really lays it out. Before, it was all about the nitty-gritty of training the model. Now, the focus has completely shifted. Things like prompt engineering, which is basically the science and art of talking to the AI to get what you want, are suddenly critical. And building a good user interface, it's gone from a nice-to-have to absolutely essential. So the big takeaway here is that working with AI is becoming way less about being a deep-in-the-weeds data scientist and much more about being a creative developer or designer. The new challenge isn't just how do we make the AI smarter, it's how do we make all this smartness actually useful and easy for regular people to use. And this all leads to a pretty profound final question for us to think about. These models, they learn from us. They learn from our books, our art, our conversations, our code, everything we've ever put on the internet. They are a reflection of us. So as we continue to build them, we have to ask ourselves, if these AIs are learning from all our data, what exactly are we teaching them? What biases, what knowledge, and what creativity are we passing on? It's something to think about.